Hello, welcome to Astronautics for Exploits. This is Dr. Ayanshola Ogundele. Interplanetary space exploration missions, humanity's step towards interplanetary colonization. The focus points are as follows: interplanetary space exploration and interplanetary space exploration missions. For several years, humans' curiosity to expand its knowledge and unravel the mysteries of the universe has led to the design, development, and launching of various interplanetary space exploration missions. Through various interplanetary space missions, humans have been able to understand the processes responsible for shaping the rocky planets more than 4 billion of years ago, to map Bennu's global properties, and to have a better understanding of the solar system's terrestrial planets, such as Mercury, Venus, Earth, and Mars, as well as Earth's moon. Examples of interplanetary space missions that have been undertaken are Voyager 1 and 2, InSight, OSIRI-Rex, New Horizons, Curiosity, MAVEN, Dawn, Juno, LADEE, GRAIL, Pioneer 10, Cassini-Huygens, and Stardust. The InSight, interior exploration using seismic investigations, geodesy, and e-transport, is a robotic Mars lander mission dedicated to a comprehensive study of the interior and subsurface of Mars through a suite of instruments, including a high-fidelity seismometer and a boring aid probe. OSIRI-Rex, origin spectral interpretation, resource identification, security regolith explorer, is a NASA asteroid exploration and sample return mission launched on an Atlas V rocket in September 2016. Juno spacecraft, launched in 2011, was designed to explore the largest planet in the solar system. It is aimed at conducting the most detailed geospatial up to date, exploring the structure of its atmosphere, looking for a solid planetary core, and studying other aspects of the gas giant, such as its magnetosphere. Interplanetary space exploration. Presently, various government space agencies, private space companies, and investors are championing the cause of interplanetary space exploration. Some of the reasons why interplanetary space exploration is being undertaken are to bring new knowledge on the solar system terrestrial planets, such as Mercury, Venus, Earth, and Mars, and the Earth's moon, to better understand the processes responsible for shaping the rocky planets more than 4 billion years ago, and to transform them into the worlds that we explore today. Illustration of Stardust spacecraft mission is shown in this picture. There are various reasons for venturing into interplanetary space exploration, and some of them are as follows: to bring new knowledge on the solar system terrestrial planets, to better understand the processes responsible for shaping the rocky planets, and to mark Bennu's global properties. MAVEN, an interplanetary space exploration mission, critical measurements of the Martian atmosphere so as to help understand dramatic climate change on the red planet over its history, is shown in this picture. Interplanetary space exploration missions. There are various missions that have been sent into interplanetary space for exploration, and they are Voyager 1 and 2, InSight, OSIRI-Rex, New Horizons, Curiosity, MAVEN, Dawn, Juno, LADEE, GRAIL, Pioneer 10, Cassini-Huygens, and Stardust. Each of them is as follows. Voyager 1 and 2. The twin spacecraft, Voyager 1 and 2, were launched in separate months in the summer of 1977. As originally designed, the Voyagers were to conduct close-up studies of Jupiter, Saturn, Saturn's rings, and the larger moons of the two planets. To accomplish their two-planet mission, the spacecraft were built to last 5 years. But as the mission went on, and with the successful achievement of all its objectives, the additional flybys of the two outermost giant planets, Uranus and Neptune, were explored. Artist's illustration of Voyager 1 with the orbits of Jupiter, Saturn, Uranus, and Neptune, represented by the red circles as shown in this picture. Voyager 2 was launched first on August 20, 1977, and Voyager 1 was launched on a faster shuttle trajectory on September 5, 1977. The prime Voyager mission to Jupiter and Saturn brought Voyager 1 to Jupiter on March 5, 1979, and Saturn on November 12, 1980, followed by Voyager 2 to Jupiter on July 9, 1979, and Saturn on August 25, 1981. Voyager interstellar mission designed to conduct close-up studies of Jupiter and Saturn is shown in this picture. InSight is another interplanetary space exploration mission. InSight, which is known as Interior Exploration using seismic investigations, geodesy, and e-transport, is a robotic Mars lander designed, launched, and operated by NASA as the first mission dedicated to a comprehensive study of the interior and subsurface of Mars through a suite of instruments, including a high-fidelity seismometer. InSight is the first outer space mission designed for an in-depth study of the interior of another rocky planet. Illustration of InSight robotic Mars lander designed to study the inner space of Mars is shown in this picture. The primary tasks of InSight are to determine the overall structure of Mars core, mantle, and crust, to measure the rate at which it escapes from its interior, outline a detailed evolutionary roadmap to be developed by scientists, to provide valuable information on the differentiation processes that shaped the inner planet since the formation. InSight composition is shown in this picture. OSIRI-Rex is another example of the interplanetary space mission. OSIRI-Rex, known as Origins, spectral interpretation, resource identification, security, regolith explorer, is a NASA asteroid exploration and sample return mission launched in September 2016. OSIRI-Rex arrived at asteroid Bennu in 2018 for an exploration mission of 2.5 years ahead of a return launch in 2021 and the landing on Earth in September 2023. Artist's concept of NASA's OSIRI-Rex asteroid exploration and sample return mission is shown in this picture. New Horizons, launched in 2006, is a deep space exploration mission launched to study the dwarf planet Pluto and other icy objects in the Kuiper Belt. New Horizons set the record for the highest launch speed of a human-made object, entering a trajectory to escape the solar system, set for a flyby of Jupiter before making the first ever close flyby of Pluto in July 2015. The mission aims to gain data to help scientists understand the formation of the Pluto system, the Kuiper Belt, and the transformation taking place in the early phase of the solar system. Artist's concept of NASA's New Horizons mission is shown in this picture. Curiosity is the largest rover to have ever flown to Mars, featuring about 10 science instruments so as to study many aspects of the red planet, like climate, chemical composition, radiation environment, and the planet's habitability in the past, present, and future. Curiosity launched in November 2011 and arrived at Mars in August 2012, is the first ever guided re-entry to land at an exact target. Illustration of Curiosity rover is shown in this picture. MAVEN is another interplanetary space exploration mission. It was launched in 2013 and is an ambitious science mission in orbit around Mars so as to study the planet's atmosphere and find out how and why Mars has lost the majority of its atmosphere over the course of its evolution. MAVEN set out to answer the question how the Sun may have caused Mars to lose most of its atmosphere, turning potentially habitable planets into a deserted world. MAVEN, Mars atmospheric and volatile evolution in orbit, is shown in this picture. Dawn is another example. It's a space probe which is designed to study two of the three known protoplanets in the asteroid belt, so as to look into the early stages of the solar system, of which these asteroids hold a detailed record, having undergone only minor alteration over the course of the evolution of the solar system. Dawn lifted off in 2007 and arrived at asteroid Vesta in July 2011. Artist's concept of Dawn spacecraft, designed to characterize the conditions and processes that shaped our solar system, is shown in this picture. Juno spacecraft, launched in 2011, was designed to explore the largest planet in our solar system. It is aimed at conducting the most detailed of Jupiter to date, exploring the structure of its atmosphere, looking for a solid planetary core, and studying other aspects of the gas giant, such as its magnetosphere. Juno is the second spacecraft to enter orbit around Jupiter, after Galileo mission, which was launched in 1989, and active in orbit around Jupiter from 1995 to 2003. Artist's concept of Juno spacecraft in orbit is shown in this picture. LADEE, the Lunar Atmosphere and Dust Environment Explorer, explored the Moon's thin exosphere and dust environment in order to answer long-standing questions on the formation and evolution of exosphere, which will also help understand planetary bodies with exospheres. The spacecraft also demonstrated high-speed laser communications as a pathfinder for future missions. An artist's concept of NASA's Lunar Atmosphere and Dust Environment Explorer is shown in this picture. Using a suite of three instruments, LADEE studies the density, composition, and spatial as well as temporal variability of the lunar exosphere. The mission attempts to examine the abundance and variability of dust particles that may be present in the exosphere. NASA's Lunar Atmosphere and Dust Environment Explorer Observatory, mounted on the vibration table prior to the start of testing, is shown in this picture. GRAIL is another example of interplanetary space exploration missions. GRAIL mission flew twin spacecraft ebb and flow in tandem around the Moon so as to map variations in the lunar gravitational field. The probes generated the highest resolution gravity map of any celestial body. An illustration of the twin GRAIL spacecraft mapping the Moon's gravity field is shown in this picture. Cassini-Huygens was a space research mission by NASA, European Space Agencies, and the Italian Space Agency to send a space probe to study the planet Saturn and its system, including its rings and natural satellites. The flagship-class robotic spacecraft comprised both Cassini space probe and Huygens lander, which landed on Saturn's largest moon, Titan. An artist's concept of Cassini during the Saturn orbit insertion maneuver is shown in this picture. Pioneer 10 is another example of interplanetary space exploration mission. It's a space probe which was launched in 1972 and completed the first mission to the planet Jupiter. It was the first of 5 planetary probes and 11 artificial objects to achieve the escape velocity needed to leave the solar system. Pioneer 10 crossed the orbit of Saturn in 1976 and the orbit of Uranus in 1979. On June 13, 1983, the spacecraft crossed the orbit of Neptune. At that time, the outermost planet, and so became the first human-made object to leave the proximity of the major planets of the solar system. An artist's impression of Pioneer 10 is shown in this picture. The Stardust was the first spacecraft to return a cometary sample and extraterrestrial material from outside the orbit of the Moon to Earth. In 2004, the Stardust spacecraft made a close flyby of Comet Y2, collecting comet and interstellar dust in a substance called aerogel. 2 years later, the samples made it back to Earth in a return capsule that landed in the Otto Desert. Artist's impression of the Stardust spacecraft performing a burn to depletion at the end of the Stardust next mission is shown in this picture. For more information, contact Astronautics for Exploit. You've been watching and listening to Interplanetary Space Exploration Missions, Humanity's Step Towards Interplanetary Colonization, presented by Dr. Ayoshola Ogundele, with the focus points Interplanetary Space Exploration and Interplanetary Space Exploration Missions. Thank you.